So we're looking at solving these multi-step equations. Now hopefully this headset won't die partway through because I didn't charge it last night. So we want to use multi-steps to solve the inequalities in equations. So this is very similar to what we did in the last chapter with solving multi-step equations. It's just now we have an inequality sign. And the only other main difference is if we multiply or divide by a negative, we have to flip the sign. When we multiply or divide by negative, we have to flip the sign. So when I look at this equation here, y over negative 6 plus 7 is less than 9. What is the first thing we need to do to get the variable by itself? We need to do addition or subtraction to move everything over. So what would we do for this here? We would do something with the 7, yes? So I do something with the 7 on both sides. Now, is the 7 positive or negative? Positive. Since it's positive, means we have to do the opposite of it, which would be subtracting. Because if it's addition, the opposite of addition is subtraction. The opposite of multiplication is division, and the opposite of division is multiplication. So here, because it's being added to y, we would subtract 7 from both sides. And when we subtract 7 from both sides, we get y over negative 6, because these two cancel, is less than, well, 7 minus 9 is 2. 7 minus 9 is 2. Now what we need to do is we need to get y by itself. Well, how is the y and the negative 6 connected? What's going on with those? Are they being multiplied, divided? They're being divided. They're over the top of each other, yes? Whenever we have something over something else, it's being divided. So we really have y is being divided by negative 6. So the opposite of division is multiplication. So what we need to do is we need to multiply both sides by negative 6. Because when we multiply both sides by negative 6, again, when we multiply something by a fraction, it only multiplies with the numerator. Two fractions multiply straight across. So the negative 6 would be multiplied by y. And what we would get is negative 6y over negative 6 is, would it be less than 2 times negative 6 would be negative 12? Well, remember, whenever we multiply or divide by a negative, we have to flip the sign. So since it was less than, it's now greater than. Because we multiplied by a negative number, we have to flip that sign. And what is negative 6 divided by negative 6? It's just 1, yes? So y is greater than. And you guys have the line up there. I'm not going to scroll back to the top just so we can kind of see it easier. So at negative 12, would it be opened or closed? Open, because it's not equal to, correct? Now would we shade to the left or to the right? Because what's it bigger? What is it saying is bigger? The y is bigger, yes? So we want all the values bigger than negative 12, so we would shade to the right. And that's it. That's all we have to do for this here. Because we multiplied or divided by negative. Well, here, what did we do? We multiplied by a negative. Anytime we multiply or divide by a negative, we have to flip that sign. We have to change that sign. Because when we look at this here, before I multiplied by a negative, highlighter, so not including that negative 6, but y over negative 6, is that positive or negative? The whole thing is negative, isn't it? Because of the negative 6, yes? Well, once I finish that, what is this? It's now positive, isn't it? Because I switched from negative to positive. Let's see what happened to the other side. Well, this too is positive, yes? Now what is it? Negative. Those flipped sides, didn't they? Because it went from being something positive now to something negative. The other side went from being something negative, now it's something positive. Those flipped on both sides, didn't they? So the sign has to flip as well. Do y'all see how that works? Because when we multiply or divide by negative, because it's flipping those signs, we have to flip this one in the middle. We have to flip the one in the middle to match up to it. Any questions on this here? We good with this here so far? Okay, so let's look at this next one here. So we have 2v minus 4 is greater than or equal to 8. There's a good chance that might have been y, but I just cut the tail of the y off, so we're just going to call it v. So looking at this here, what do we need to do first to solve this inequality? We need to add 4 to both sides because we need to get v by itself, and the easiest way to do that first is by moving anything that's being added or subtracted from it. Anything added or subtracted from the term with the variable. So 2v would be our term with the variable, and if we add 4 to both sides, well, negative 4 plus 4 is, they cancel out, and I'm left with 2v is greater than or equal to 12. Any questions on this here? Any questions on this here so far? So we're not completely done because we started out with 2v minus 4, but we added 4 and we just now have 2v. But we want v by itself, so what do I need to do? I need to divide both sides by 2. And v is, well, greater than or equal to 6. So we'd go to the 6 on the number line. Now, would it be opened or closed? It would be closed. Now, do we shade to the left or to the right? So what are we saying is bigger, v or 6? V. So we would shade to the right. Now, if we were saying 6 was greater, then we would shade to the left. But here, because v is greater, v is the bigger number, we shade to the right. We shade towards the number that are bigger than 6. And that's it. That's all we have to do on this here. Questions on any of these here so far? We good with these here? These are kind of refresher from last year? Yes? Comfortable with the ones with variable on one side. So we're going to look at these here, variables on 2 sides. Now, what we need to do first, steps. Step number 1 is we need to get the variables on the same side. Get the variables on the same side. And we would do that by adding or subtracting. We're going to do that by adding or subtracting the variables from one side to the other. So here we have 6x minus 5 is less than 2x plus 11. So we're going to add or subtract. So would you want to move the 2x, move everything to the 2x's side, or everything to the 6x's side? So we'll move everything to the 6x. So I would need to do something with the 2x, yes? So at this point here, we're not really worried about multiplication or division. It's really all adding and subtracting. So what would I do? Would I add 2x to both sides, or would I subtract 2x from both sides? Nope. So is 2x positive or negative? It is positive, yes, because it doesn't say. So if we have to do, since it's positive, the opposite is, so we would, yes, we would subtract. Because it's positive, we're going to subtract, because 2x minus 2x is 0. So they cancel out. So on this side here, we just have 11. I'm going to probably have to move that over. Now 6x minus 2, 6 minus 2 is? And we have 4x minus 5. So our first main step is to get all the variables on the same side. Do we have that? Step number 2. Get them by themselves. So we got them all together. They all got grouped together. Now they want to be by themselves. They want everybody else to go away. They want those kids that are grade lower than them to get away. Stay away. Yes? So those pesky 8th graders are right here. So what do we need to do with the 5 to get rid of them? We need to add 5 because negative 5 plus 5 is what? It cancels out at 0, yes? They go away? If only that were that simpler, right? 11 plus 5 is 16. So the first main step that we had was we were getting the variables on the same side. We did that here by subtracting 2x from both sides. Then we got those since we have them all on the same side, we need to get them by themselves. So we moved everything else that wasn't that variable x, to the other side. Now they're almost completely by themselves. We just have the 4. So these two, 4 and x, are being multiplied or divided. They're being multiplied. When they're next to each other, it's multiplication. When they're over the top of each other, it's division. So the opposite of multiplication would be division. So we would divide both sides by 4, and we get x is less than 4. Now, do I need to flip it? No, we only need to flip it is when I multiply or divide by a negative. And it's whatever we're multiplying or dividing has to be negative. Whatever we're multiplying or dividing, if it's negative, then we flip it. If what we're multiplying or dividing is negative, then we flip it. So our number we're focused on is 4. And would the circle be open or closed? It'd be open because it's not equal to. Now, what is bigger, x or 4? 4. We're saying 4 is bigger, yes? So are the numbers, so we're saying we don't want numbers bigger than 4, yes? So where are the numbers that are smaller than 4? Are they on the left or the right? They'd be on the left. Left is always smaller, right is always bigger. So the left side will always be smaller than that number. The right side's always going to be bigger than that number. So here we're saying x is less than 4. We want the number smaller than 4. So we would say to the left. Any questions on that one there? So we good with that one there? So let's look at this one now. Some of the ones I skipped over, we'll go back to those here in a minute. Now looking at this here, we have a set of parentheses, yes? Simplify those first. Simplify those first. Because we're wanting to get the variables on the same side. That first step is still true. But this 3n minus 1 here is kind of locked down. It's locked inside of those parentheses, so we need to get it out. So what we're going to do first is we're going to distribute, we're going to multiply every term inside of here by negative 4. So negative 4 times 3 is negative 12. So we have negative 12, and then we have the n. Negative 4 times negative 1, a negative and a negative would make a positive, so we'd have plus 4. Negative 12n plus 4 is greater than negative 12n plus 5.2. So now we want to get the variables on the same side, yes? So do we want to move everything to the negative 12n side or everything to the negative 12n side? Well, the variables are the same, aren't they? So I'm just going to I'm going to move them this direction. So since it's negative, it means we would add, yes? Add what to both sides? We would add 12n to both sides because 12n and 12n would, well, here they would cancel out, yes? So 4 is greater than 5.2. Is this a true statement? No, maybe if I change it, let's get all the numbers. Let me subtract 4. I'm going to subtract 4. Maybe this will change it. Because 4 minus 4 is 0. It is greater than, well, that wasn't true, and that's still not true, is it? No. So since this is not a true statement, well, think back to equations. What did we say when an equation turned out to be a not true statement? So what do you think this is? This here is no solution. Now, it's just because we have that set of parentheses where we distributed doesn't mean it's automatically no solution. It just worked out for this one here that it was. Okay? So, so good. So here it worked out no solution. Questions on this here? So we'll look at some more with this here. I'm going to add a page. So on the back or somewhere where you have spare paper, because I think the very back should be blank, yes? So on the very back, I want you to put this note. So no solution. False statement. Zero is greater than 1.2. 0 is greater than 1.2. That's a false statement, yes? So in these inequalities, if we come up with a false statement, 0 is greater than 1.2, it is no solution. It's no solution. And actually, we can draw this equal sign with 2 arrows on either side. You'll cover this in geometry, it's biconditional. It means they imply each other. This implies that. They both are true. Because if it's a false statement, then it's no solution. If we get a no solution in an inequality, it means that we came up with a false statement. Now, obviously, or kind of following from that, we could get all real solutions. Well, if we have all real solutions, we didn't come up with a false statement, we came up with a true statement. 7 is greater than 0. Now, with these false and true statements, one of the key features is that there is no variables. So hopefully you notice with these two here, there aren't any variables left. We don't have n is greater than 7 or 7 is less than x. Like there's no variables left. 7 is greater than 0. That's just a true statement. There's no case, there's no point where 7 is not going to be greater than 0, correct? I mean, it just won't happen. Unless we start talking in specific cases with inflation. You've covered inflation in government, yes? Or the price of the dollar. If we print more money than there actually is value to it, it loses its overall value. Fidget spinners, when they first came out, they were expensive. Now you can pick them up on pennies on the dollar at any kind of store, yes? That's inflation. There's more product than there is demand. That'd be the only case where this works out, because if inflation hits to a certain point, they're not worth anything. There's so many of them, we don't know what to do with them. That's the only case where that might be hit, but that's, again, certain special cases. But for what we're looking at, 7 is always going to be greater than 0, yes? No variables, true statement, all real. If it's a false statement, then it's no solution. And that's how these kind of work. No solution are all real. And it will give you, there will be some in the homework. If it is that, you just put all real solutions and we're done. So, let's see here. Let's look at this one. Okay? Let's look at this one here. So the first thing we need to do is we need to distribute, because this is back. We all find it? So the first thing we need to distribute is the 4. Well, 4 times 2b is 4 times 3 is. What do we need to do? We need to minus 8. Now, when it turns out the variables have the same number and sign, there's a good chance they're going to both cross out. Because here we're going to get negative 3 is greater than 12. That's not true, is it? So that little line, if you're wondering what that is, does not, because you remember when not equal to, we draw a line through it. We can do the same thing with inequalities, because we're saying that negative 3 is not greater than 12. That's a false statement. So this is no solution. It is no solution. It is no solution. Questions on this one here? So we good? Last one of the day, we're going to look at this one here. And then I think we're pretty good. We feel comfortable with these. So what do we need to do first here? We need to distribute, yes? So we're going to distribute the 2. We're going to do 2 times 5w. And what is 2 times 5w? 2 times 5 is 10, and then we have, and then 2 times negative 1 would be negative 2, yes? So minus 2. Well, hey, we have same variable, same sign, yes? So I'm just going to subtract 10w from both sides. Because 10w is positive, so we would subtract it to eliminate it from one side. But hey, it worked out. It eliminated it from both sides, didn't it? So negative 2 is less than or equal to 7. Is that true? So this here is all real solutions. So this here is all real solutions. And that's all we have to do for this here. So yes, well, the graph of it would be the whole line. We'd fill the whole line in because it's any number. Any number works, so we just fill the whole line in. And that's all we'd have to do there. So no solutions, you don't fill the line in if it asks. And if it asks to graph this, and it didn't specifically say graph, but if it did, you just shade the whole line in. Shade everything, because it's all of it. Questions on this here? If we feel good with this here, I'm going to stop it right here.